In this video, we're going to talk about how to solve some more complex logarithm equations that require quadratics. Alright, so in order to solve a quadratic equation, we can either use factoring or the quadratic formula. So remember, we have those kind of two options, and then all we're going to do is mix in the logarithms now. Alright, so the way we talked about solving logarithms using this one-to-one property, if I'm able to get just a single log on the left and a single log on the right, the only way these two things can be equal is if the insides are equal. So we pretty much just ignore the logs and just set those two insides equal. One extra thing we have to be careful with logarithms, at the very end, we have to check for extraneous solutions, because sometimes we'll find the answer to this equation, but it actually won't work in the original equation because logarithms have specific things we're allowed to plug in. We're not allowed to plug in negatives into the parentheses of a log. I just have to double check that to make sure it works. Alright, so here's an example. Log of x plus 5 equals log of 14. And we're looking here, we have a single log on both sides. You can't do this one-to-one property until you have a single log with the same base. So we can't use the one-to-one property yet because there's these two logs, but we have our log properties that we have a plus sign in the middle. You can kind of smush these together like that. Alright, so I can smush two logs together and multiply the insides if there was a plus sign in the middle. And now I have a single log and I can kind of ignore them and just set the insides equal. Alright, so now I have this new equation I have to solve. First thing I see, I have to distribute this in to kind of see what I'm working with. And now that I've distributed, I see this x squared right here. X squared means it's a quadratic, which means I can do all of our quadratic methods. If I'm doing factoring or the quadratic formula, I have to get 0 on one side, so the first thing I'm going to do is subtract 14 from both sides. And again, from here, it's kind of up to you. You could do the quadratic formula. I see this one. Whenever I see that 1 in front of x squared, I know there's that nice factoring shortcut that means I don't have to do the whole splitting method. So I'm just looking for two numbers that add to 5 and multiply to negative 14, and that's positive 7 and negative 2. All right. So because I see that kind of shortcut, I know it's pretty quickly to factor this quadratic. All right. And the reason we factor is because now I can split this up into two smaller equations. I can take x plus 7 and set it equal to 0, and x minus 2 and set it equal to 0. Here I have to subtract 7 from both sides. Here I have to add 2 to both sides. All right, so if you did all of this on a test or something, you get almost all the credit. All right, but there's one thing we have to do with logs that we don't have to do with a lot of other types of equations, and that's check for extraneous roots. So if I look at 2, if I try to plug in 2 here, 2 I can plug into the log. 2 plus 5 is 7. I can plug that into a log. So 2 is good. Try to plug in negative 7. Negative 7 can't go into a log because I can only plug in positive numbers into a log. So I can't plug in this negative 7 to my original equation, which means I can just cross it out. And my final answer is just 2. And so that final step of making sure you cross out any extraneous roots is how you're going to get full credit for these logarithm equations. All right, next equation. All right, we're trying to solve. We see there's multiple logs, so again, we have to use our rules for logarithms to combine them. We have this minus sign, so when we have a minus sign, we divide the two insides. And now, just a single log, I kind of ignore them, and I just set the insides equal to each other. And now I have to solve this. First thing I'm going to do is get rid of this fraction, so I'm going to do that by multiplying both sides by x plus 1, because on the left-hand side, when I multiply by x plus 1, it cancels. And I just get 12. On the right-hand side, I distribute this x in to x plus 1, I get x squared plus x. Again, now I look at this equation I have, and I see it's got an x squared, it's a quadratic, so I want to get 0 on one side. So I do that by subtracting 12 from both sides. Again, you could look at this and do the quadratic formula with 1, 1, and negative 12 as your a, b, and c, but I see that I can factor this one, especially because there's the shortcut with the 1. I just get x plus 4 times x minus 3. Right, those add together to 1, multiply together to negative 12. All right, and the reason we factor is because now I can break this up into my factor equals 0 and my other factor equals 0. Here I subtract 4, here I add 3. And again, check for extraneous roots. If I try to plug in -4 plus 1 is -3, and that's bad. I can't plug -3 into a log, so that one's out. 3 plus 1 is 4, that's fine. 3 is also positive, so 3 does work, and I just get that one solution. All right, so here's one for you to try on your own. More similar to the first example, go ahead and try to solve this equation. I'll show you the answer in 3, 2, 1. All right, the final answers you get are 2 and -2. All right, but one of these is an extraneous root. If I try to plug in 2, I get 2 and 8, that's fine. All right, so this one's fine. But if I plug in -2, I try to plug in -2 in this log, I cross that one out. All right, so I combine. All right, from here, I see it's quadratic, I get 0 on one side, and here I factored it doing the difference of squares, so another shortcut. If you don't remember the difference of squares shortcut, you can always just do the splitting method and separate them out. All right, one other way you could solve this equation from here, all right, once I see it's 4x squared equals 16, there's no x term. All right, so when there's no x term, I can also use square roots to solve this, so I could say this is x squared equals 4, dividing both sides by 4, to get the x squared by itself. Then I could do square roots, and x equals plus or minus 2. And then you would go through the same process. +2 would work, -2 would not work. So just +2 would be the answer. But don't forget, you also have square roots as another method. You can only do that when there's no x term. So this one I can't do because of the x. When there's no x term, I could also use square roots as an alternative method. All right, so this is nothing new. You know how to solve quadratics. You know how to combine logarithms. So you've done all these processes before. It's just combining it all. And again, to kind of ease your mental load, if you look at this as one big long problem, sometimes you can kind of get lost. So I would look at it as kind of smaller problems. All right, just until you get rid of the logs, it's kind of one problem, and then take a breath, and then solving the quadratic is another problem. All right, so if you kind of use little pauses in your work as you go, it can really help you kind of separate out what you're actually trying to do. All right, but nothing really new in this video, just kind of putting together some things and keeping it all organized and kind of understanding what you're doing.